Okay, so sorry I'm 5 minutes late, but I was having problems getting the image the right way around. I think we should be okay now. So what I think I'm going to do, if any of you have got any quick questions, that's great. If not, I'm just going to just work through a few of the questions from the May 2017 paper, just in case some of you just want to watch a few basics. But if you've got any questions, please do ask. So this is the 25th of May 2017 paper. So this is question 1. So question 1a, we've got to factorize 10a plus 25. So we've got to look at the common denominator. What's the biggest factor that goes into both 10 and 25? Or the biggest number that goes into 10 and 25 is 5. So we take 5 outside the brackets. And 5 times what gives us 10a? Well, that's 2a. 5 times 2a is 10a. Get the sign right, that's the plus. And 5 times what gives us the 25? Well, that's 5. So our final answer is 5, open bracket, 2a plus 5, close bracket. And obviously they're easy to check. You just expand the brackets to make sure you get back to 10a plus 25. Now for part B, we've got to factorize 7w squared minus 4w. So what's the biggest common factor of the two terms? Well, it's w. So we take a w outside the bracket. Open up a bracket. W times what gives us 7w squared? Well, that's 7w. Get the sign right. It's a minus. And then w times what gives you 4w? Well, that's 4. Easy peasy. Okay, so part C, we're expanding the brackets. So p2 times p, then p2 times minus 5. So p squared times p is p cubed. Get the sign right, it's a minus, and p squared times 5, 5 times p squared, just 5p squared. Now for part D. So we have the pair of brackets here. So we're going to start off with the first term in the first bracket and do x times x, and then secondly x times 7. X times x is x squared. Secondly, x times plus 7 is plus 7x. Then moving down to this clause for the minus 3. Minus 3 times x is minus 3x. Minus 3 times plus 7 is minus 21. So we've expanded. That's got rid of the brackets. And now we have to simplify. So we gather up the like terms. We gather up the x's. So we get x squared plus 4x minus 21. Now for part E. So work out the value of g when f is 2. So g is going to be 2 cubed. Then we're going to take away 7 lots of 2. So t cubed is 8 minus 7 2s are 14. 8 minus 14 is minus 6. Hi JJ, hope you're well. Just working through some GCSE questions, but you're very welcome to follow a few if you want, but don't be too surprised if some of them are quite tricky for you. Right, so for part question 2, we've got to enlarge the shape of scale factor 2 and center 7 3, and we've got to label this new shape Q. Mind you, you get your sister to watch JJ, that would be good. She's got her exam on Thursday. Right, okay, so for part A, so we've got to expand it with scale factor 2. Here's our center. So just take a point, say bottom right-hand corner. Oh, excuse my dog barking in the background. So we've got to make this point here be twice as far away. So it's currently 1, 2, 3, 4 squares to the left. So it's got to be 8 squares to the left of the center of enlargement. 1, 2, 3, 4, 5, 6, 7, 8. So that is our new That's on a new bottom right-hand corner. So the shape's got to be twice as big. So it's not going to be 2 along, it's going to be 4 along. It's not going to be 1 up, it's going to be 2 up. It's not going to be 1 across, it's going to be 2 across. 4 up, 2 across, then all the way down. So that's enlarged the shape, scale factor 2. Okay, for part B on the grid, rotate P 90 degrees anti-clockwise about the 0.73. Well, I haven't got my tracing paper here to do that, so I think I'm going to give that one a miss. Yes, Jonathan, you do get tracing paper in the exam. Okay, so I'll just go through the process. I'm not sure if you know how to, but you are given tracing paper. Okay, so basically you put tracing paper over the whole area. Okay, so tracing paper over the whole area. Obviously, you're going to draw around this shape. What I suggest you do is then you put an arrow pointing upwards on the tracing paper as a guide. You're then going to put your pen on the center of enlargement as a pivot. And as we're going 90 degrees anti-clockwise, shift your paper around into the arrows pointing to the left, and then copy through the shape underneath. So you just press on the indentation, press on the shape, creating an indentation underneath. And that will be your answer. If you, I forgot to bring some tracing paper home, otherwise I would do that now. Okay, so question 3. So here's a list of ingredients needed to make some apple and blackberry crumble for 4 people. Work out the amount of apples needed if we're making apple and blackberry crumble for 10 people. So we're going from 4 people to 10 people. So 2 ways of doing this. You can either decide to go back to 1 person first of all. So you divide all of these ingredients by 4, giving you amounts for 1 person. It's absolutely fine. So you're dividing back by 4 to get amounts for 1 person, and then you would multiply forward by 10. So one option is to divide by 4 and then multiply by 10. So for the apples, we'd be doing 300 divided by 4, which is 75, and then taking our 75 and multiplying it 10 to get 750. Alternatively, you could just do a scale factor. You could say, how do I get from 4 to 10 people? What's my scale factor? So 4 times what gives me 10? Well, do 10 divided by 4 on your calculator, and you'll see you get a scale factor of 2.5. So basically, all of these ingredients have to be multiplied by 2.5. So with your apples, 300 times 2.5, and that again is going to give you the 750. Now, for part B, Roland makes apple and blackberry crumble for a group of people. He uses 920 grams of blackberries. Work out the number of people in the group. Okay, so we know that, so blackberries, we've got 115 grams is enough for 4 people. Okay, 115 grams blackberries for 4 people. So this one, I think I would scale back to 1 person. So get back to 1 person. So 115 divided by 4 gives us 28.75 grams for 1 person. Now we've got 920 grams, but it's so 920 grams. How many people will this be for? Well, we need to scale up from 28.75 to 920. So do 920 divided by 28.75. 920 divided by 28.75, and that gives us 32 people. Okay, question 4. So we've got the table showing information about the lengths and centimeters of 4 leaves. Write down the modal class. Now, modal means most. So which is the most we have? Well, our biggest frequency is 14. Okay, we've got 14 leaves, which are between 3 and 4 centimeters. So that's the biggest number. So what is their modal class? You just copy down this length over here. So literally copy it down exactly. So that will be our answer for part A. Now we've got to work out an estimate for the mean length of the 40 leaves. Now it's an estimate because we don't have the data to hand. We know 4 leaves are between 0 and 1 centimeter long. but we don't know how long they actually are. So the best we can do is go halfway along and take a midpoint. So for each of these lengths, we're going to take a midpoint. So 0.5, 1.5, 2.5, 3.5, and 4.5. And then we're going to cross multiply. Okay, so we're going to assume these 4 leaves are exactly 0.5 centimeters long. Assume these 5 leaves are exactly 1.5 centimeters long, and so on. So how much length do we have in total? We just cross multiply these numbers here. So we get 4 times 0.5, which is 2. 1.5 lots of 5, which is 7.5. 2.5 lots of 11, which is 27.5. 3.5 lots of 14, which is 49. And then 4.5 lots of 6, which is 27. And these are all little bunches of length, aren't they? 4 lengths, length. If we add all of that length up, 2 add 7.5, add 27.5, add 49, add 27, and we get 113. Now that 113 length is being shared across the 40 leaves. So divide that by 40. Be careful, don't divide by 5, the number of rows, which is what people often do. And we're getting a length of 2.825 centimeters. Okay, question 5. So use your calculator to work out the value of that. I don't know if this is going to show up on the calculator very well. It probably won't, but I would definitely use this button here. Okay, the fractions button. So that opens up. You probably can't actually see it, but once you open that up, that allows me to put 7.3 and 2.1 into the numerator. Move using the blue arrow. Move down below into the denominator and pop in your 6.4. Then moving across out of the fraction with the blue arrow to the right, then plus 2.2 squared gives me 6.30875. So write down all the figures on your calculator display. So that's what I've done. And then for part B, give your answer to 3 significant figures. Now remember, that's 3 digits in total. So 1, 2, and 5 are above. So our final answer is 6.31. 3 significant figures. So, question 6. On the grid, draw the graph of y equals 2x plus 4 for the values from -3 to +3. Okay, so if I were you here, I would just, well, first of all, reflect on what shape this is going to be. We've just got y's and x's and numbers. This is just going to be a straight line. There's no squares or anything to turn it into a curve. So we just need 2 or 3 points, really. So if I were you, I would just set up some nice, easy x values. Let's say 0, 1, and 2. And for each of these, just substitute it into the function to see what y values we get. So when x is 0, 2 lots of 0 is 0, 0 add 4 is 4. So there's our first coordinate, 0, 4. So plot 0, 4, nothing along the corridor, 4 up the stairs. Then move on to x being 1 and pop that into the function. 2 lots of 1 is 2, 2 and 4 is 6. So there's our second coordinate, 1, 6. So plot the point 1 along, 6 up. And then 1 for luck, I think. I mean, obviously you only need 2 to do a straight line, but I would do 1 for luck. So when x is 2, 2 2s are 4, 4 plus 4 is 8. So we get the coordinate 2, 8. And then just get your ruler out and draw a straight line, but make sure the straight line goes all the way from -3 to +3. Okay, so draw a straight line all the way down, but making sure it covers the whole of that graph paper. Okay, question 7. Excuse me. So we've got to calculate the length of AC. So let's let AC bx. So first things first, which bit of Pythagoras is where it's side, side, find a side? So here, yes, we've got a side, we're finding a side, but there are angles involved. It's not side, side, find a side. So we know it's SOHCAHTOA. So we're going to be using those little ratios. So I would just start off by just writing down what the ratios are. Now, the way I learned that is silly old Hitler caused awful havoc to our armies. You might have your own acronym, but however you do it, you are going to need to know those three ratios. So with this particular question, I'm picturing myself at the angle. This side is adjacent to me, next to me. This is the side I need to know, which is the hypotenuse. So on this occasion, it's adjacent and hypotenuse, so we're using cosine. Zoe's just asking, what exam paper is this? Zoe, this is this paper. It is the Edexcel Higher IGCSE. All right, it's the IGCSE paper 3H from 25th of May 2017. Okay, I mean, I have got GCSE papers here as well, but I just thought unless people have got specific questions, I was just going to work through this paper from last summer. To be honest, if you are doing the GCSE, it's all very similar material, so it's all good practice. Right, Andrew's asking, can you use the sine rule there? Well, no, you can't. You'd be using the sine rule, Andrew, if we happen to know what BC was. So if the question had said BC was something, then we would know the opposite sine and be finding the hypotenuse. So in this particular situation, you can't as things are. However, if you want to make things slightly complicated, but it's absolutely fine, if you go and work out that angle there, Andrew, which is easy enough to work out, that's going to be what, 68. All right, then is that going to what am I talking about? We're trying to find, yes, if we work out this angle here as 68, then you could use the sine rule. That's just getting complicated, Andrew. Just stick with what you're given. And on this situation, given we've got this angle, we've got the adjacent and the hypotenuse, so we should use cosine. So we've established that we're going to be using cosine. After the chosen ratio, you always go and put the angle in. So that's 22, equal sign. And then you've got to make sure you get the ratio the right way around. We need to put our adjacent over the hypotenuse. So that's 14.9 over x. So this is one of those which is a bit more complicated. All right. Now we've got to get x being the subject. So with the algebra here, it's going to be a two-step process. First of all, we're going to multiply by x. So x times cos 22 equals your 14.9. And then secondly, to make x the subject, you're going to divide by cos 22. So x equals 14.9 over cos 22. Okay, so just be careful. It's not one of these easy ones where it's just x over 14.9, in which case you just multiply by 14.9. So just put your algebra hat on at this point, just cos 22, and that gives me a length of 16.070 ... Read the question. It says 3 significant figures. That means 3 digits, 1, 2, 3, so 16. Zoe's asking, how many marks on each paper do you think will guarantee a grade 7? Are you GCSE, Zoe, or are you doing the GCSE? With regard to the GCSE, here's the grade boundaries. I haven't actually got the grade boundaries for November 17 yet. I haven't slotted those in, but looking back at last summer, Zoe, you were needing to get about, this is on the GCSE. Yeah, I see. Yeah, that's the one you're doing. Last summer, you were having to get 42 out of 80, 41 out of 80. So basically, you were having to get half marks. When you're just over half marks, you were needing to get about 52% to get a 7. I haven't got the November grade boundaries to hand, Zoe, and to be honest, they're always a little bit misleading because that tends to be the people who are retaking from the summer, so it's not very much, it's not a representative sample. So in short, I think, what was your question? How many marks in each paper do you think would guarantee a grade 7? I reckon 45 would guarantee a grade 7, 45 out of 80, okay, for the GCSE. Jonathan's asking about the IGCSE. Jonathan, your guess is as good as mine. I mean, we just haven't had an IGCSE 91 yet, so I really don't know. I'm hoping if it was as hard as the papers they've released, you know, the mock and the specimen paper they released recently, it's going to be quite low. I mean, I would hope it's going to be similar to the GCSE. We just don't know. We're just going to have to see. I just don't know. We're sort of this summer we're in. You know, we just don't know. So, Jonathan, school 22 is a 4. Let's see. Yeah, 22 is a 4. Well, let's just compare that to the GCSEs. 22, yeah, we'll see. That doesn't sound way off, Jonathan. I mean, I think the GCSE at 22 was giving you a 5, but are you talking about 22? Because we're not quite comparing like with like here, Jonathan, because these GCSEs were out of 80. Are you talking about, I would imagine, Jonathan, you're talking about 22 out of 100, 22%, okay? I would say that would be about right. Looking at the GCSE, you were needing to get 17% to get a 4. Yeah, it's just saying out of 100. So yeah, I would say 22 out of 100, you'd be pretty unlucky not to get a 4. And try and aim to get a bit more. You know, some of the easier stuff is pretty easy. So is that what you're aiming for? You're hoping to get a 4? So if you are, just stick to all this easier stuff. Just if I were you, I would just literally just practice the first 12 questions of the paper and forget everything after that. So it's sort of like the stuff I'm doing at the moment is, oh, you want to get a 7? Okay, well, you need to better do the whole lot then. Okay, I think to get a 7, you're going to be needing to get, you know, you're going to need to be getting, I don't know, 55, something like that. So really, you need to be attempting all the questions, I would say, apart from 1 or 2. So, yeah, which is doable. There aren't that many which are inaccessible. Right, anyway, let's carry on. So, question 8. This one is a bit boring, but there we go. So we've got to work out a percentage increase. So to work out a percentage increase, you first of all have to work out the change, divide this by the original amount, and times by 100%. By the way, Jonathan and Zoe, if you're still there, if there are any specific questions you want me to go over from any of the papers, you know, do feel free. I'm quite happy just to leave this paper alone and go and I've brought home all the IGCSE and GCSE papers from recent years, I think. So if there are any questions you're stuck on, just tell me which paper and I'll dig it out and see if we can have a look. But until anyone has any specific questions, I'll just keep on turning the pages on this, I think, just for a bit longer. 6880 take away 640, which is what that is, 2880. Divide that by the original amount, which was 640. And multiply that by 100 to turn it into percentage. So 28.8 divided by 640 times that by 100, and that gives us 4.5%. I think, if I can read my. Okay, well, what I suggest you do, Jonathan, if you're interested in the probability and the construction lines things, if you can find a specific question, then I can. I'm quite happy to. Ah, it's you, JJ. Hang on. No, we've got 2. Yes, yeah, sorry, Jonathan. You're asking probability and construction lines. Yeah, if you can find some specific questions, then I'm quite happy to look at those. I think if I just try and do probability or construction lines from scratch, I just won't know if I'm you know, if I'm hitting the mark. And JJ, you're asking, could you start the revision pack 2 questions? Yeah, of course you can. If you finish the revision pack 1 and you want to start the revision pack 2 questions, that's great. Okay, right. So Zoe's asking, could you go through the non-calculator mock 3 autumn 17 paper? Oh, I'm really sorry, Zoe. I don't have the mocks to hand. I've only got the I've only brought the original ones home. I could probably try and dig that out at school tomorrow, but I'm sorry, I don't. I haven't got the mocks to hand. So the only ones I've brought home with me are the real life papers, both GCSE and GCSE from the last few years. So I'm afraid those will have to have to stay. Yeah, Jonathan, right, right. You've gone right back to June 11. Yeah, doesn't sound very helpful. I don't think I've brought them back as far as that. It's not to say I can't dig it out. So right, so Jonathan, you're looking for the 6th of June 2011 3H paper. I could probably lay my hands on that. I probably got it on the system. Is there a particular question you wanted me to go? I don't really want to have to do the whole paper. All right, so question 17. All right, let me I'll go and try and dig that out. So we're talking yeah, that's fine. I'll see if I've got it. I can probably so we're saying 6th of June 2011, 3H, question 17. And that's quite a long time ago. I'm just gonna see if I've got if I've brought that, if I've actually got that to hand. So June, right. So that's IGCSE, isn't it? So yeah, I'm sorry, John. I don't go that far back. I've only got them as far back as 2013. If you can dig something out 2008, no, 2013 onwards. Right, okay, so right. All right, and then Zoe's saying if you go to Reg F. Harding's YouTube channel, they have the paper on their Google Drive. And which one did you like them? Right. So Zoe, if I go on that, have you got a specific question you had in mind? I think, Jonathan, I think there's loads more probability questions that are more up to date. If you could just try and dig something out on one of the more recent papers, I can lay my hands on those. I can probably dig out the June 11 one from school, but okay. Right, so what I'm going to try and do, because it'd be quite interesting for me to have a look at these things. So Zoe's asking for the, so if I go to the Reg F. Harding, I'll give that a quick Google. And we're looking for, what was she looking for? The non-calc Mock 3, autumn 17. This is GCSE, isn't it? Question 9. Right, I'll have a quick play with that. Let's just go on to see if I can find that. I can see he's got the, right, okay. Yeah, he's got some papers here. Ed Excel practice. No, I can't see his, oh, here we go. What have we got down here? All right, this might be getting a bit more narrow. Right, so November, autumn 2017. Right, I'm just looking at these Reg Harding ones. There's buckets of them. I'm just trying to find. He hasn't. They all just seem to be one after the other. Right, paper 2F, June 17, but we want mocks. Mock, here we go. Mock 3, autumn 17. Oh, I can see a video. I don't really want the video. I want the actual paper. Here we go. Mock 3, autumn 17. Oh, I can see a video. I don't really want the video. I want the actual paper. Right. No, no, that's just a blooming video. That's no good. You can just listen to him as listen to me. Oh, I can't see where he's got his actual paper. All right, so I see that little note. Right, I'll have another go. Right, so there's a Reg Harding thing. Right, I've left it now. I'll go back and have another look. Reg F. Okay, so I've got that. I've got says on the side of the landscape pictures says Mr. Harding's Google Drive. I'm not sure I've got Google Drive. One just says join Google Plus. I think that's something that I'm just going to have to look into. I'm not very familiar with all this stuff. I mean, I can join Google Plus, but that's going to take me forever. It's forever, I think. Oh, I knew the picture of the dog. All right. Sorry, Joey, I can't see. I see lots of pictures of dogs. Is there Can you just tell me what the question was? It's probably not as simple as that, is it? I might just Google the paper. I don't know if it's. When are we saying? You're saying it's. Let me go back to where you said what paper you wanted. Autumn 2017. Where are we? That's. No, I can't get that, Zoe. I mean, I think if you were able to take a photo of the question, you could just direct message me on Twitter, you wanted just to send it through that way. My Twitter is just Maths by Mr. W. That's probably the quickest way. I'm not very familiar with all this rubbish, as you can tell. So I think I'm just ages here trying to find that paper. So if you've got a specific question on okay, so yeah, if you can do that, that'd be great. I'll keep an eye out for it on I'll keep an eye out for it on my Twitter feed. All right. And to remind you, Zoe, it's at Maths by Mr. W. All right, you just I think I've set it up so it takes all messages. All right, if you send that through to me, I can just then see it on the screen, and then I'll. Same with you, Jonathan. If you want hasn't worked very well with me actually laying my hands on the questions. So if you've got any those specific questions you're talking about, if you just want to take a photo of them and just direct message them to me on Twitter, I can just pick them up and just do them straight off the screen. Okay, so I've got it. Yeah, cool. So the STEM diagram shows the age and years of 25 people. Key 1 to 7 record. Draw a box plot of the information. Okay, right. So Zoe, for a box plot, okay, so in short, a box plot's going to look like this. Okay, so where this is the lowest number, so looking at your stem and leaf, can you see that the youngest age is 1/7, so that's 17. Bye, JJ. So that's 17 is the smallest one, and then again, can you see, Zoe, that the oldest person is going to be 4/1 at the bottom, so that's going to be 41. So that's going to be your one at the top. Now we've now got to do the median. This is going to be the median, the one in the middle. So we've got, let me see, how many people have we got there? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 1, 2, 3, 24, 25. Oh, it says 25 people. Sorry, I should have counted. So the middle one's going to be 25 add 1, which is 26, the 13th person. So go along to the 13th person. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that's going to be 28. So 28 is going to be the middle one. Now, this lower quartile is the quarter of the way up. So that's half of the first 13. So that's going to be your seventh one. Okay, because think about it, you've got 6 people, then you've got your quarter of the way up, then another 6, then your middle, then another 6, then your 3/4, and then the final 6. Okay, so our lower quarter is going to be our 7th one along. So 1, 2, 3, 4, 5, 6, 7. So that's going to be 24. On our upper quartile is going to be halfway across the top 13. So that's going to be the 7th last. So 1, 2, 3, 4, 5, 6, 7, which is going to be 32. So just going over that again. So let's just I think the easiest way to explain this, Zoe, is if we just for the purpose of me explaining it, we just rewrite that stem and leaf as if it was a list of numbers. So we've got 17, 17, 18, 19, 21, 22, 24, 24, 25, 25, 26, 27, 28, 29, 29, 30, 31, 32, 32, 33, 34, 35, 36, 40, and 41. So there is a list of the 25 people. Now the middle person, okay, the middle one is going to be your 13th along. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There is your middle one. Because imagine them all lined up. You've got 12 people before you, 12 people after you. So how did I work out that was going to be the 13th person? I took my 25 people. I then added 1, which is 26. And then I halved it to get 13. So that's how I got my middle person, my 28th person. Well, sorry, my 13th person, he's got an age of 28. Now, for the lower quartile, you now go and look at this stretch of ages before the median. And we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 there. Okay, so we need to go and find the middle of those. So if we sort of work our way in. Okay, actually, I got it wrong before, so it's lucky it got me to check. So when we work our way in, our middle two, all right, our middle of the first is between 22 and 24. So that's got to be 23. So really, you're working out the median of the first half. Okay. Now, with regard to the upper quartile, we really need to work out the median of the second half. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So halfway along these 12. So 1, 2, 3, 4, 5. So it's between us. That one there is going to be halfway up our second half, if you see what I mean. Because we've got 1, 2, 3, 4, 5, 6 before us, 1, 2, 3, 4, 5, 6 after us. So I think our upper bound is actually going to be 32.5. I think that's right. Does that sort of make sense? Now, what is the probability that this person is 30 years of age or older? Well, that's okay, isn't it? It's the 30 or older. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 who are 30 years of older. So that's 10 out of the 25. Okay, so that's your final answer for A part 2. Okay, it doesn't say you have to simplify it. Obviously, you could simplify it and make it 2/5 if you wanted to. So that's that question. If you've got another one, Zoe, feel free to just direct message me on Twitter on that. Same with you, Jonathan. If you're still there, if you wanted to just direct message me on Twitter, I'll just keep an eye out for that. I think I'll keep going for another 9 minutes to make it a nice round hour. Okay, yeah, Jonathan, yeah, they come through. Cool. Right. Okay. So, Jonathan, I'm looking at that the construction one. I use ruler and compasses to bisect the angle of ABC. You must show your construction lines. Okay. So this is easy enough, Jonathan. So basically the question looks like this: A, B, C, and we need to work out an angle bisector. So in short, this line is just going to be bisecting this angle. It's going to be halfway up this angle, okay? So what you do, you get your compass, you put the pin here, and you just do a small little arc, like that. Now what that does, it just establishes those 2 points there. You then get your compass again. You can change the length if you wish, or you don't have to, but most people just tend to make it a little bit longer. And putting the pin here, you just go and do a little arc. And then you move over and put the pin here, keeping the compass length the same, and go and do another arc. And then basically keep those construction lines on your, keep your construction lines there, but then get a ruler and then draw a line from B all the way through to where those two arcs cross, and that's your final answer. That will be an angle bisector, which is splitting this angle in two. All right, so step one, to draw this small little arc with the pin here for your compass. This establishes these 2 points. Then step two, do an arc from here, do an arc from here, and where they cross is where you're going to draw your straight line through from B. So that's your angle bisector. So hopefully that answers your first question, Jonathan. Right, so I'm just trying to find your... Okay, right, I see. I'm just going to... Right, so, right, okay. Now the next one says expand and simplify. I think it says x plus 5, x minus 3, x plus 3. Can you just confirm that's what it says? I'm sure I can probably make this bigger, but I think that's what it says. X plus 5. Yeah, it does cut. Cool, right. Okay, this is easy. So really just take a pair of brackets, doesn't matter which two you take. Why don't we just take the second pair, and you just multiply those out, leaving that x plus 5 well alone. So he stays well alone. You're just going to multiply out this this second pair. So we're going to do x times x, x times plus 3, minus 3 times x, minus 3 times plus 3. So that gives us x squared plus 3x minus 3x minus 9. And obviously those two 3x and minus 3x cancel out. So that just then leaves us with x plus 5 to be multiplied by x squared minus 9. And it's another pair of brackets. Another pair of brackets. So we're going to do the x times x squared, x times the minus 9, 5 times the x squared, 5 times the minus 9. So that gives us x cubed minus 9x plus 5x squared minus 45. And then I would just, for tidiness, just sort of put it in decreasing powers of x squared, but that will give you full marks. But I would personally put my x cubed, then my x squareds, then my normal x's, then my normal numbers. That would be your final answer. Okay, so it doesn't matter what order you do it. So you just multiply out a pair of brackets completely, and then take that and multiply that by the other bracket. So hopefully that was fairly straightforward. Okay, right. Okay, yeah, nice one. The next one, this circle theory question. So what we've got there is we've got a circle. We've got this inside it there, then this going off like that. And we're called A, D, C, B. That angle there. Oh, okay, that's quite hard to see. I wonder if I can make this bigger. Yeah, I can. Right, so that's 103. And that there, oh yes, then this is a chord here at A, sorry, yeah, that's a tangent, rather, tangent at A, and that angle there is 39. And we're being calculate the size of angle ADB. So we've got to work out this angle here. Okay, right. So first things first, the alternate segment theory tells us that this angle here is 39 degrees. This is one of the weird circle theories. One of the weird circle theories tells us that the alternate segment theory tells us that that angle is 39 degrees. All right. So quite simply, where you've got the triangle inside a circle, that angle there equals that angle there. That is the alternate segment theory. So we start off by saying angle DBA equals 39 degrees, alternate segment. Was it sector or segment? Alternate sector, segment. I think, do you know what? I can't remember. I think it's sector. You might just want to Google that and just check whether it's sector or segment. I can't, it slipped my mind. Okay, it's one of them. Okay, but that's all you have to say. Right, so we know that angle is 39. Secondly, we know that this angle, because we can work this angle out because this is a cyclic quadrilateral, and opposite angles in a cyclic quadrilateral add up to 180 degrees. So that angle must be 77 degrees. And you would say angle DAB equals 77 degrees because opposite angles in a cyclic quadrilateral total 180 degrees. Now we're nearly there then, aren't we? Because we've got angles in a triangle. So you would just say x equals, so it's going to be 180, take away 39, take away 77. That's going to be 64 degrees. And you would just say, because angles in a triangle total 180. Segment, thanks Zoe. Yeah, it's segment, alternate segment. All right, alternate segment theory. I should have known that. Slipped my mind. Alternate segment theory. Okay, so that is that question. Yeah, do you have to put all the reasons? Yes, you do. Absolutely, you do, Jonathan. It says give a reason for each stage of your working. So every single one of those needs to have a sentence written down. Absolutely. Right. Okay. So that then takes us to, all right, so transformational graph question. Okay. So let's just make that bigger. Yeah, good choice, this one. Okay, so basically we have got a shape given to us where we have got the maximum point is at 3, 5. And we're being asked to write down the coordinates of the maximum point of the curve with the following equation. So this curve is y equals f of x, and we're just doing the transformation of this curve. Now, part 1, we've got to write down that coordinate for this graph. Now, there's a nice, easy way, or a nice shortcut for these. If the change is inside the function, like it is here, inside the function, then it affects the x coordinate, the x value, and it does the opposite to what it says on the tin. So because this is saying +3 and it's inside the bracket, we're actually going to take away 3 from the x coordinate. So our answer here is going to be 0, 5. Now for part II, we've got the y equals 2 f of x. Now this is now outside the bracket, it's outside the function. So this affects the y values, but it does do exactly what you would expect. So it multiplies it by 2. So this one up here affected the x values, but did the opposite. You were taking away 3. This is outside the function. It affects the y values and does what you would expect. So the x value stays unchanged on 3. The y value becomes 10. Now for part 3, where we've got y equals f3 of x, 3x. This again is inside the bracket, so it affects the x values. But rather than timesing by 3, you are going to divide them by 3 inside the bracket, opposite to what it says on the tin, but affecting the x values. So we're going to divide the x value by 3. 3 divided by 3 is 1. So that's going to be 1, 5. Now, the curve with equation y equals f of x is transformed to give the curve with equation y equals f of x minus 4. Now, this is outside the bracket, so it's going to affect the y value and do what you would expect. So it's going to take away 4 from the y values. So the whole curve is going to be just shifting down 4. Okay, so I would just say for this, it's a transformation by the vector 0 minus 4. That just basically shifts everything down 4. It's just a shift downwards by 4. So that finishes that question. And yes, I think that last one, you're just showing me what paper they came from, I think, Jonathan. So I think that's it. So let me just check. I picked up your 4. I picked up Zoe's. Okay, I think at that point, my dog's barking. I think I might go. I might stop in a minute. Okay, so good luck, Zoe. Good luck, Jonathan. Good luck, others who popped in. Just before you sign off, just let me know. I mean, I'll probably aim to do this again nearer the exam. So I think 7 o'clock works for me. Just I'm definitely going to do it Wednesday night. I'll probably do it again tomorrow. So just let me know. Yeah, if you've got any more queries, I'll aim to come back on. But I tell you what, I will also. But just direct message me anyway on Twitter, and if you direct message me in advance, I can just sort of prepare my answers in advance. But I'll aim to go back on at 7 o'clock tomorrow, I think. Okay, cheers, guys. Bye.